Hi, friends. I hope everyone's doing well today. Wanted to do a little bit of programming with you. I'll go ahead and share my screen and we can get started. All right. So today I wanted to look at chapter 19, lab 7, square root. And it says, given a floating point number as an input, output the square root of that number. Use the appropriate math function. Okay, before we get started, I want to set a few expectations. So I've got my handy dandy little setup next to me. Oh, upside down. There we go. So let's just do squares and square roots. So if I have 2 and I square it, that's going to equal 4. If I've got 3 squared, that's going to be equal to 9. And if I've got 4 squared, that's going to be equal to 16. This is the same thing as saying 2 times 2 or 3 times 3. And this has an exponent of 1. And so it's the same thing as 3 to the 1 plus 1, which is the same thing as saying 3 squared. And so to go in the different other direction, you can also look at, 6, the square root of 16 is going to be 4. The square root of 9 is going to be 3. And the square root of 4 is going to be 2. So what they're asking for us to do today is simply implement a function that does this. The last two were a little more involved, a little more complicated. So hopefully this one's a little bit more fun. This one's going to be probably fairly short. So I'm going to use one of my favorite environments, just the command line. So I'm going to CD on my computer, change directories into my Git folder because I keep all my Git files in my Git folder. I'm going to use our SWOSU computer science Python examples folder. Forget all the, I've got a lot of stuff in there. We're going to do the one for computer science 1. And then we're also, what's in there? Hey, this is chapter 2. So we'll go to chapter 2. And this one, it's not a Jupyter notebook. So I will just leave it out here in the wild. I'll make a new file, and this one we're going to call square root.py. All right. So as a good practice, I almost always forget what it is that I'm working on. And so as a good practice, I like to come into my text editor and just kind of remind myself what it is we're working on. So there we have it. There's our problem statement. And I'm going to start by doing a test. So hey, it works. So like I said, that's just a test to make sure that my code works. We don't need that anymore. Instead, I'll say, let's create a variable, and I'm going to call this user input. I'm going to say equals input, which is the library lookup that asks the user for their input. And I'm going to add a queue. If you're using a Zybooks, the Zybooks doesn't like queues, but I like to use queues because I program out in the wild and I work on these machines, and it's not always the same. So I'm going to ask what cool. And so I also like to tell the user what they entered. So they entered user input and clean up with the punctuation and such at the end. And let's just see if this works. So we'll run it again. I'll do 9. You entered 9. Now we need to go and find, what did it say? Use the appropriate function from the math module. So let's go in here and let's do an internet search for Python math square root. There it is. All of these are good. I'll start with this top one. Hopefully it works well. So yeah, there it is. Math square root. And it says import math and then math.sqrt. Okay, so I'll come in here. I'll put my import statement and come down here. I'll say print. All right. So let's, oh, punctuation. That's why it didn't look the right color. There we go. So we're going to import the library and then we are going to grab the user input, give the user some feedback, do a calculation, and then give them the final answer. Let's see. Oops, my blue dot of shame up here reminded me I haven't saved yet. Okay, now we've saved. We come back here. Let's test it. Let's do the square root of 9. This is good feedback. This is important to know. This is a good reminder, and I think a lot of other people, I can tell you at least 2 other students in Computer Science 1 have had this same problem. It's the problem says type error. You must be real, not string. So let's talk about that. In here, when you're grabbing the user input, it comes in as a string. Python print type. So let's see how to do this. Type a variable name. So okay. Let's see if I can grab this. Let's add that sentence in here. I have no idea if this will work or not, but I'm going to try it. And this could all end in tears. So let's see how far this runs. Okay. You entered 9 with a type of class string. So one of the things that we can do is we can come in here and we've got a few places we can do this. I'm going to do it here while we're grabbing the input. And whatever comes in as an input, I want to store as a float, not a float. Float. Yep. Okay. Now let's try this. So we put in 9 and it says you entered 9.0 with a type of class float. The square root of 9.0 is 3.0. Okay, let's do a couple more tests. I know for our notes we had 16, that's 4. And then let's try 4. And that is 2. Okay, well, let's get a little more crazy with it. Let's try 10. The square root of 10 is just a little more than pi. Cool. All right. So that's good enough. Let me do something right quick. All right, so that should be pushed up to the cloud on the main branch. So let's go look at see what that looks like here in GitHub. So here's Python examples, CS1, chapter 2. And here we see the square root.py. And that's all of our code that we just worked on together. So, all right, friends, that one was hopefully a little more straightforward. There's some other fun math libraries that you can go and explore. I guess let me share my screen right quick. I'll just show you some that you could go play with. Let's see. Let's do. Let's see if, ooh, here it is. Math functions. Ceiling, so number theoretic. This is where it's going to round up. Lots of fun functions in here. So this is the modulus function. This is also sometimes called clockwork arithmetic. Again, good times. Greatest common denominator, divisor of two numbers. You can determine if two numbers are close. If it's infinite or not a number is NAND. Lots of fun things. It just keeps going. You know, the math library just keeps going. There's the trig functions. I know some of you out there are a huge fan of your circles. Good times. Other, hyperbolic functions, special function. Oh, the error function. That's a compute traditional statistical functions such as the cumulative standard normal distribution. Good times, especially for our psychology friends. Constants. I didn't realize this. I was in graduate school and I was like, E, what are you talking about? E. I had never heard of E. And I was talking to one of my buddies that had a bachelor's degree in mathematics, and he's like, yeah, E is a number. And I actually, let's see. There we go. All right. So it is the base of the natural logarithm. It's an important mathematical constant. E is occasionally called Euler's number after the Swiss mathematician. Notice how I just blurted out Euler but couldn't say mathematician. I'm not actually sure if it's Euler or Euler, but I always say Euler. 0, 1, pi, and the square root of -1 all are important, cool things. Here's there's other definitions. There's some really cool math properties that it has. I don't remember them from calculus, but it's a good time. But the point of this discussion is when you're working in Python, what you're going to find is that there's a lot of other people that have done a lot of really cool things. And so in general, you shouldn't have to roll your own very often. You very much should be able to go lean on other libraries, find other things, and you should be okay. Well, friends, hey, always a good time. I hope this is beneficial. Have a great week, and hopefully I'll get to see some of you at Show and Tell on Friday, or I'll get to see your uploads and discussions. Thanks and take care. Bye.